Hello, am I audible?
Yes, sir.
Okay, so it's already 5 and only one student have joined till now. So I will start the discussion session right now. Let the others join because today there are going to be some numericals mainly based on the earth pressure theory and that needs to be solved in the class itself. I'll be giving you some time to solve it like the previous days, but today I believe we are going to need some more time to solve because it is the sums are a bit lengthy. Okay, it also has some diagrams. So, okay, the meeting has started. The recording has also started. Okay, I'll just close it. Okay, so yeah, good evening. This is the live session, discussion session of the course Soil Mechanics Geotechnical Engineering 1. This is the 11th week. The topic is Earth Pressure Theory. In the last discussion session, who is there in the class? Abdul. Abdul, can you just give me a brief recap what we have done in the last discussion session?
We have we have done all basic cases like active, passive, and rest conditions,
Yes.
and the fundamentals of theoretical aspects covered,
Okay.
and also cohesive soil for C5 soil, active and passive conditions completed.
Completed. Yes. But the numericals portion were not yet touched in thorough, right? Because I've given
Yeah,
only
only
four.
except critical height remaining didn't attempt.
Yes, yes. And how to draw the earth pressure diagrams and all, we haven't touched on that.
Yes, sir. Yes, sir.
Okay, and last day you came up with a question like about that wall friction,
Yes, sir.
isn't it? Wall friction. So whatever I have done my study, I couldn't find any exact like answer to the question. But there is a
Yes.
formula which uses the Rayban's graphical system. That formula, I believe, if I tell you right now, I won't tell you. I'll tell you at the end of the class. Please remind me. Okay.
Okay.
I
Okay.
will be explaining whatever I have understood. I will be explaining it to you using that particular formula only. Okay.
Okay, sir.
Okay. Okay. So here I'm going to start dictating the questions. Write down the questions and today write down the questions very carefully because the numericals are a bit lengthy and you will need some more time. Okay.
Okay, sir.
Okay. 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 So earth pressure theory part 2. I'll start dictating the questions now. Okay. The first question is, in the case of passive state of plastic equilibrium, the major principal stress is the, in the case of passive state of plastic equilibrium, the major principal stress is the, your options are vertical pressure, pore pressure, lateral pressure, or none of these. In the case of passive state of plastic equilibrium, the major principal stress is the vertical pressure or the pore pressure or the lateral pressure or none of these. Next question. The effect of cohesion in soil is to reduce the active pressure intensity everywhere by, your options are 2C tan alpha, where C is the cohesion, alpha is the failure angle made by the failure plane with the plane of the major principal stress. It is 45 plus pi by 2. 2C tan alpha 2c cos alpha, 2c sin alpha, or 2c cot alpha. C is the effective cohesion or cohesion in the soil which is required in the equation of active earth pressure for cohesive soils. Sir Miles has joined. Okay. Yeah, Ravindra Kumar, please write down the questions as I'm dictating them, like the usual classes. You get time to solve them. Okay. Yes. So the question is, the effect of cohesion in soil is to reduce the active pressure intensity everywhere by, the options are 2c tan alpha, 2c cos alpha, 2c sin alpha, or 2c cot alpha. C is the cohesion and alpha is the failure angle. Angle meant by the failure plane with the plane of the major principal stress. Okay. Next question. In the Bell's equation for active earth pressure on cohesive soils, the pressure intensity for Z equal to 0 is, in the Bell's equation for active earth pressure on cohesive soils, the pressure intensity for Z equal to 0 is, your options are minus 2c tan alpha, minus 2c cot alpha, 2c tan alpha, or 2c cot alpha. Again, C is the cohesion, alpha is the angle made by the failure plane, the plane of the major principal stress. I'll repeat the question. In the Bell's equation for active earth pressure on cohesive soils, the pressure intensity for Z equal to 0 is minus 2c tan alpha, minus 2c cot alpha, 2c tan alpha, or 2c cot alpha. Okay. Next question. For smooth walls, the value of wall friction is taken as, for smooth walls, the value of wall friction is taken as. Here, the conditions which are mentioned, it goes every time for active earth pressure at rest, and passive earth pressure. Every time when there is a smooth wall, then what is the value of wall friction that is being assumed in the analysis? Your options are 1 by 3 of phi. Phi is the angle of internal friction. Option 2, 2 by 3 of phi. Option 3, 3 by 4 of phi. And option 4, 0. I repeat the question. For smooth walls, the value of wall friction is taken as 1/3 of phi, 2/3 of phi, 3/4 of phi, or 0. Phi is the angle of internal friction of the soil. Okay. Okay. This completes the MCQs. Now, every question is a numerical. Please write down the question in detail, the entire question as a dictate, write down detail, and copy the data very carefully. Okay, because there are many data, it might be a little bit confusing at times. So write down the question very carefully and copy the data well. Okay. Next question. A 6-meter high vertical wall supports a saturated cohesive backfill with a horizontal surface. The top 3 meter of the backfill weighs 18 kilonewton per meter cube and has an apparent cohesion of 18 kilonewton per meter square. The bulk unit weight and apparent cohesion of the bottom 3 meter of the backfill are 20 kilonewton per meter cube and 24 kilonewton per meter square respectively. What is the likely depth of tension cracks behind the wall? If tension cracks develop, what will be the total active pressure? Draw the pressure distribution diagram and determine the point of application of the resultant pressure. I'll just repeat the question once. A 6-meter high vertical wall supports a saturated cohesive backfill with a horizontal surface. The top 3 meter of the backfill weighs, that is the unit weight is 18 kilonewton per meter cube and has an apparent cohesion of 18 kilonewton per meter square. The bulk unit weight and apparent cohesion of the bottom 3 meter of the backfill are 20 kilonewton per meter cube and 24 kilonewton per meter square respectively. What is the likely depth of tension cracks behind the wall? If tension cracks develop, mark this part very carefully. I have asked if tension cracks develop, what will be the total active pressure? So, this question is asking you to find out the total active pressure considering the fact that tension cracks had already developed. Okay, this part is important. With this, draw the pressure distribution diagram and determine the point of application of the resultant pressure. Okay. Is it done? Is the question copied? Hello?
Yes, sir. Yes, sir. Yes, sir.
Okay. Okay. Next question. A retaining wall 4 meter high supports a backfill having cohesion equals to 20 kilonewton per meter square, angle of internal friction equal to 30 degree, and unit weight is gamma equals to 20 kilonewton per meter cube with horizontal top flush with the top of the wall. That means at level with the top of the wall. The backfill carries a surcharge of 20 kilonewton per meter square. If the wall is pushed towards the backfill, compute the total passive pressure on the wall and its point of application. The previous question was asking to find out the active pressure. This question is asking to find out the passive pressure. flush with the top of the wall, it means at level. Okay. I'll repeat the question once. The retaining wall 4 meter high supports a backfill. C equals to 20 kilonewton per meter square. Phi equals to 30 degree. Gamma equals to 20 kilonewton per meter cube with horizontal top flush with the top of the wall. The backfill carries a surcharge of 20 kilonewton per meter square. If the wall is pushed towards the backfill, compute the total passive pressure on the wall and its point of application. Okay. I hope the question is copied. I'll go to the next question. A wall of 6 meter height retains sand having a unit weight of 20 kilonewton per meter cube and friction angle of 30 degree. If the surface of the backfill slope upwards at 15 degree to the horizontal, find the active thrust per unit length of the wall. There is a force per unit length of the wall. Here the backfill is inclined at an angle of 15 degree. I'll repeat the question. A wall of 6 meter height retains sand having a unit weight of 20 kilonewton per meter cube and a friction angle of 30 degree. If the surface of the backfill slope upwards at 15 degree to the horizontal, find the active thrust per unit length of the wall. Okay. Okay, these three questions which I have mentioned, I'll be solving it right now, and the rest of the questions I have pasted the solution. You can copy the solution when I dictate the answers, or else this video will be available and this file will also be available in the Google Drive. Okay. Okay. A retaining wall 4 meter high has a smooth vertical back. The backfill has a horizontal surface in level with the top of the wall. There is a uniformly distributed surcharge load of 36 kilonewton per meter square intensity over the backfill. The unit weight of the backfill is 18 kilonewton per meter cube. Its friction angle and cohesion are 30 degree and 0 respectively. That is, the material is cohesionless. Determine the magnitude and point of application of the active pressure per meter length of the wall. Magnitude and point of application of active pressure per meter length of the wall. I'll repeat the question once. A retaining wall of 4 meter high has a smooth vertical back. The backfill has a horizontal surface in level with the top of the wall. There is a uniformly distributed surcharge load of 36 kilonewton per meter square intensity over the backfill. The unit weight of the backfill is 18 kilonewton per meter cube. Its friction angle and cohesion are 30 degree and 0 respectively. That is, the friction, the angle of inclination is 30 degree and the cohesion is 0. That means it is a cohesionless soil, might be sand. Rather. Determine the determine the magnitude and point of application of active pressure per meter length of the wall. Things to note down is it has a horizontal surface in level with it above the wall, and the data given is unit weight 18 kilonewton and the surcharge is 36 kilonewton per meter square. Okay. So if you draw the pressure distribution diagram also, it will do something like this. I will not show the entire thing. So to draw it and find out in the diagram what is the point of application of the active pressure per meter length of the wall. I hope you know this because we will be applying the same things in the previous sums also. I hope it is clear. Is it clear? Is there any doubt?
No, sir.
Okay. I'll go to the next question. In the previous problem, that is the last question which I have told, if the water table rises behind the wall to an elevation of 1.5 meter below the top, that is up to a depth of 1.5 meter from the surface of the soil, there is the water table. And the other conditions remain same as the previous problem. In this case, determine the total active pressure and its point of application. The only thing is given here is that the submerged unit weight of the cohesionless soil. The submerged unit weight is 12 kilonewton per meter cube. Okay, this is submerged unit weight, and assume that there is no change in the friction angle due to submergence. Generally, in sands after submergence, apparent cohesion arises. Apparent cohesion arises, which leads to the bulking of sand. Have you heard about bulking of sand?
Yes, sir.
Yes. So, which condition is responsible? The apparent cohesion, right? The sand, they do not have any cohesion, but apparent cohesion arises because of submergence in water, due to which, up to a certain point, after the increment in volume of water, the sand shows bulking. Okay. So in this case, we have to assume that there is no change in the friction angle, because if there is change in the cohesion, there might be a change in the friction angle also. But here we have to assume that the friction angle is constant. The friction angle is constant due to submergence. Okay. Same question like the previous one. Water table rises to a depth of 1.5 meter below the top, and submerged unit weight is 12 kilonewton per meter cube. Okay. I'll go to the next question. A vertical excavation was made in a clay deposit having unit weight of 20 kilonewton per meter cube. It caved in after the depth of digging reached 4 meter. I had given a similar sum in the last class also. It caved in means it crumbled after the depth of excavation was 4 meter, that is unsupported length maximum will be 4 meter. Taking the friction angle to be 0, calculate the value of cohesion. If the same clay is used as a backfill against a retaining wall up to a height of 8 meter, calculate number 1 total active earth pressure and number 2 total passive earth pressure.
Sir, KCA,
Yes, what?
KCA, total active earth pressure.
Yes, total active earth pressure.
Is it before formation of the crack or after formation of the cracks?
No, the crack formation is different. The crack formation is a different, what to say, event. The soil in which the crack formation happened, the soil which caved in after digging a depth of 4 meter, that same soil is being used, suppose in a different place as a backfill. Okay, in a different place as a backfill. Suppose there are two locations A and B. Okay, there are two locations A and B. In location A there is a clay which after excavation up to depth of 4 meter it caved in, it crumbled or cracks formed. Okay, now I am taking the same soil in location B and placing the soil as a backfill against a retaining wall which has a height of 8 meters. Okay, considering that it is everything is like normal, like the backfill is horizontal level with the wall and everything as per the Rankins earth pressure theory. Okay, now in that case, in location B you have to find out the active earth pressure and the passive earth pressure. The only thing you need to use over here is the cohesion value which you will be obtaining from the first situation, the same way you have done in the last class. In the previous class also there was a sum like this, no? To find out the cohesion. In the same way, you will find out the cohesion value and use it to find out the total active earth pressure and total passive earth pressure in the location B, in the other location where the backfill is used against a retaining wall up to a height of 8 meter. In the first place, okay, the backfill is having a unit weight of 20, it is constant in both the locations. In the first place, it caved in after reaching a digging depth of 4 meter. Clear? Is it clear?
Yes, sir. But actually, when you go to the second site, when you backfill this material,
Hmm.
it's going to be once again active case C5 soil with phi is equal to 0. You
Yes, same soil, exactly with the same soil. In the first place, there was no support. Okay, there was no support of the soil. That's why it caved in after 4 meter. But now there is a backfill, right? It is giving a support. It is giving a lateral support, right?
yes, sir.
Yes. So if you think that up to a height of 8 meter it will cave in, there is no need to consider something extra. Even if the tension cracks form, okay, considering the tension cracks is forming, what is the normal Rankins equation for the cohesive soil that you have to use? Okay,
Okay, sir. Done.
is it clear?
Yes, sir.
Yes, there is nothing like exceptional in this case. Whenever you use a cohesive soil, then the cohesion has an effect on the active pressure and the passive pressure also, right? So considering those effects, you have to find out the active earth pressure and the passive earth pressure. Okay. Okay. This is the last question. A soil mass is retained by a smooth backed vertical wall of 6 meter height. The soil has a bulk unit weight of 20 kilonewton per meter cube and friction angle of 16 degree. The top of the soil is level with the top of the wall and is horizontal. The soil surface carries a uniformly distributed load of 4.5 kilonewton per meter square. Determine the active thrust in the wall per meter and its point of application. Same questions. It is nothing different, just given for practice. Write down the equation very carefully. Very easy to solve. The friction angle is given as 16. Yes, friction angle is given as 16 degree. 20 kilonewton per meter cube, 6 meter height, surcharge load of 4.5 kilonewton per meter square. I'll repeat the question once. The soil mass is retained by a smooth back vertical wall of 6 meter height. The soil has a bulk unit weight of 20 kilonewton per meter cube and friction angle of 16 degree. The top of the soil is level with the top of the wall and is horizontal. If the soil surface carries a uniformly distributed load of 4.5 kilonewton per meter square, determine the active thrust on the wall per meter and its point of application. Okay, clear? Any doubts regarding any question?
No, sir.
Okay, so how much time do you need to solve these questions? I can start at 6 o'clock or 5:55. What do you say? 25 minutes will be okay?
Yes, sir.
Okay, so I'll start at 6 o'clock. You first do one thing. Ravindra and Abdul. You first start with the numericals only. Start with the small numericals, which has less volume, which will require less effort. Okay. Then the first question is quite big numerical, along with this one and this one also, which are connected. So I'll just ask you to solve the first question, first, second, third, fourth question, and fifth question. First, fourth, fifth question at the end. It is a big, a bit bulky. Okay, and solve the other numericals first, and then go to the MCQ. MCQ are very easy. You can solve it in a while. When I start solving the answers, I'll also start with I'll start with the first question, the numericals first, and then I'll go to the MCQs. Okay. So you can also do the same thing. So I'll start with the numericals and the small ones first, and then go to the MCQ. If you have some time, then you can go to the big numericals. Anyway, you'll get in the solution by the end of the day. Okay. So you can start solving them.
Sir, can I see once the question
Which question? Tell me.
after sloping 15 degrees question, sir?
After sloping 15 degrees question. This one, right?
You have a two cases with water table, without water table. Case one I want, sir.
No, case that water table question does not have a sloping 15 degree.
No, no, sir. After the sloping question, I want next one.
Acha, next one you want. This one
Yes, sir.
or the second part, water table part?
First part I want.
Yes, first part. This is the first part.
Okay, just a minute, sir. I will copy it.
Yes, yes, copy.
Thank you, sir.
Okay, fine. Start solving. Is the PPT visible?
Yes, sir.
Okay, so have you done? Have you solved the questions?
Yes, sir.
All of them?
Yeah, done, sir.
Okay, good. And another one, Ravindra Kumar, have you done the questions? I think his mic is off. Are you there in the meeting, Ravindra Kumar? Okay, I think he is there, but he's not speaking. Okay, very good. We have done. So I'll start discussing the solutions. Okay, so I'll start with the numericals first. Okay, I'll at the end I'll go to the MCQs. Okay, so the first question I'll be solving. I'll start with this. Yes. So you have solved this question, right, Abdul?
Yes, sir.
Yes. So what was asked? The depth of the tension crack behind the wall.
Yes, sir.
So what is your answer?
2 meters.
2 meters. And then it was asked total active pressure given
One.
that tension crack has developed. Yes. What is the total active
Yes,
pressure?
sir.
What is the answer?
117 kilonewtons, sir.
Newton per meter. Okay. Kilonewton per
Yes,
meter
sir.
of the length, and the point of application is from the base.
1.256 meter from base.
Yes, 1.25 meters from base. Okay, so you have done very good. So
Thank you, sir.
it saves some of my effort actually, because I don't need to explain it that much. But I will solve it anyhow for the others to see. Okay. So in this case, we are told that we have been given a saturated cohesive backfill, isn't it? Saturated cohesive backfill. So what is the first assumption we can make using this statement about the angle of friction, which is also a recursive parameter? What is the first assumption that we can make with this statement, saturated cohesive backfill? Here you can see the angle of friction is not given, right? Hello? Yes, Abdul, you can speak.
Yes, sir. Assume as a 0.
Yes, yes, yes. Okay, I think your mic is not working properly. Yes, angle of friction will be equal to 0. So the first thing I'll write over here is the angle of internal friction over here will be 0. Okay, angle of friction is 0. Now if the angle of friction is 0, then for the case of active earth pressure, considering cohesion, considering saturated clay, will be what? Will be PA. I can write like this: small PA equals to, it will be, it is saturated soil. I can write gamma SAD into Z minus 2 of twice of the cohesion. Okay, twice of the cohesion. In some books, you will find undrained cohesion. That is the cohesive value determined from the unconfined compressive strength test. Okay, I'll be using C over here. So this is the equation. Okay, and for the tension crack, what is the formula? If Z0 is the tension crack depth, what is the formula for tension crack?
2c by gamma.
2C divided by gamma. Okay, 2C divided by gamma SAT. Now, yes, here there are two cases given for the top soil and for the bottom soil. Okay, so using equation 1, if Z equals to 0, what are we having? We are having at Z equal to 0 at the surface, we are having this one reduces to 0, and the active pressure is equals to minus 2C. The topsoil, the cohesion is 18, so it is minus 36. I am not writing the unit, but you write the units. Okay, minus 36. Okay, I'll write. Okay, this is the active pressure at the surface. Now we need to find out the tension crack depth, isn't it? Tension crack depth. So assuming that the tension crack is forming at the top soil and it is not extending to the bottom layer of the soil, we can write like this: Z0 equals to 2C, Z0 equals to 2C, that is 2 into 18 divided by gamma sat, divided by gamma sat, that is 18. So here we get equals to 2 meter, like this, isn't it?
Yes, sir.
Yeah. Now, for drawing the pressure distribution diagram, I hope you have drawn the pressure distribution diagram, obviously, because otherwise you cannot solve it. You have drawn it,
Yes,
right?
sir. Yes,
Yes.
sir. I have drawn, sir.
Okay, okay. Just you have right correctly, just validate it. Okay. Now we'll first find out at specific levels. Okay, specific levels. We'll see like this at z equals to 3 meter first. Z equals to 3. Z equals to 3 meter. Okay. And we will be using this formula PA equal to gamma set Z minus 2C. So at Z equals to 3 meter, PA will be equal to how much? Gamma set Z, that is 18 into 3 minus 2 into C, minus 2 into 18. Give us 18 kilonewton per meter square. It is for the topsoil. Okay. If Z is more than 3 meter, Z is more than 3 meter, what will we get? For the topsoil, we'll be adding this only 18 to 3, and for every Z more than 3, we'll be adding the bottom soil that has, I think, 20, it has kilonewton per meter cube. Yes, 20 into Z minus 3. We'll write like this. Minus, we'll subtract the value of cohesion of the bottom soil, because at that time the topsoil will be acting as a surcharge. So 2 into 24 will write. Okay, 2 into 24 will write, and that will give us an equation like this: 54 minus 48 is 6. 6 plus 20 into Z minus 3. 6 plus 20 into Z minus 3. Okay, this is the equation at Z more than 3. So if we consider the bottom soil, this is for the top soil. Top soil. If Z equals to 3 for the bottom soil, then putting this in equation, we get how much? We get Z equals to 3 minus 3, 0. We get PA for the bottom soil as 6 kilonewton per meter square. Okay. Now the depth of the entire soil is 6. So at Z equal to 6 meter, 6 meter, PA will be how much? 6 minus 3, 3 into 20, 60 plus 6, 66. 66 kilonewton per meter square. The pressure distribution diagram will be somewhat like this. Isn't it? The pressure distribution diagram will be somewhat like this. This will have in the topsoil at the surface 36. Here it will be 0. This is negative pressure. This is the positive pressure. This will be equals to 18 for the bottom soil. For the top soil, this will be 6 for the bottom soil, and this will be 66. Isn't it? Abdul, have you got this?
Yes, sir. Yes, sir.
Yes, good. So this will be 2 meter, I guess, because tension crack depth. This will be 1 meter topsoil, and this is entirely how much? 3 meter.
3 meter.
Yes, this is entirely 3 meter. Now, what you have to do is you have to find out the active pressure. In the question, I have mentioned that you have to consider tension crack has developed. If tension crack has developed, Then for considering the active pressure, this part will be ignoring. Okay, this part will be ignoring and will be only be concerned with the positive pressure below 2 meter. So you can find out like this. This is 6. This is 66 like this. This area also you can find out by using the trapezium. Okay, I'll be using 2 diagrams like this, not the 3 diagrams. For this case, for the topsoil below the tension crack, what is the pressure? P1, it will be half into Ka into how much? Okay,
VT.
no need to find out K. We have already found out 18. So half into 1 into 18, that is 9. I guess 9 kilonewton per meter, right?
Yes.
9 kilonewton per meter. And for this, what is the formula for area of a trapezoid?
H by 2 A plus B.
H by 2 A plus B. So this is 3 by 2 into 66 plus 6.
It's 108.
Yes, it is 3 by 2 into 66 plus 6. It is equals to 108. 108 kilonewton per meter square. Okay, 108 newton per meter square. So adding these two, obviously we can get the entire total pressure. If this is the location of P1, suppose this is the location of P2, then we can find out the location. This will be acting at a depth of 3 meter plus 1 by 3, isn't it? 3 meter
Yes,
plus
sir.
1 by 3. That is the depth of P1 will be 3 plus 1 by 3, 3.33. And the location of this is P1, sorry, this is P2. Location of P2 will be 3 into 1 by 3, I guess. 3 into 1 by, no, sorry, this is
H
the
by 3.
this is the
Trapezium.
formula of trapezium. Yes, h by 3 into b plus 2a plus a plus b divided by a plus b, right?
Yes, sir.
Yes. So if this is P2, I'll write this formula over here. This is an important formula. If you know, P2 will be h by 3 b plus 2a divided by a plus b, because I'm not considering the triangle and rectangle separately. I'm considering the trapezoidal as a whole. So this is h means is 3 by 3, b plus 2a. It is 66 plus 2 into 6 divided by 66 plus 6. What is the value you are getting? I guess 1.08, right? 1.08.
1.083. Yes, sir.
Yes, I'll write 1.08.
3.
1083, okay, 1083 meter ZP2, and ZP1 is 3.33. Okay, so now you can find out the application. If this is I guess P, I'll write over here somewhere around here P. So if it is Z bar, so how will you find out Z bar? Z bar equals to P1 into ZP1 plus P2 into ZP2, isn't it?
Yes, sir.
Divided by P1
P1 plus
plus
P2.
P2. That means P1 is 9. 9 into ZP1, 9 into 3.33 plus P2, that is 108. 108 into ZP2, 1.083 divided by 9 plus 108. In that case, the value of P, total pressure, will be found out as 117 kilonewton per meter square, isn't it? 118 kilonewton per meter square. So we can
So,
find out, yes.
sir, the units are kilonewton per meter, sir.
Oh, sorry. Yes. Unit is not kilonewton per meter square. Kilonewton per meter. Yes. 117, because I am finding out the active thrust per meter length of the wall. Thank you. Per meter.
Okay.
Okay. So this will not also not be kilometer. It will be Newton per meter. It's Newton per meter. Yes. So what is the value of Z bar?
1.256 meters.
Yes. Rounding off to two different places. 1.26 meter. Okay, so in this pressure diagram, in this pressure distribution diagram, the total active thrust of 117 kilonewton per meter length of the wall is acting at a distance of 1.26 meter from the base of the wall. Is it clear?
Yes, sir. Done, sir.
Yes. The next question. Retaining wall supports a back plate. You have also solved this question, right? Abdul, you have
Yes,
solved it?
sir. Passive question.
Yes, passive question you have solved it, right?
Yes, sir.
Okay. Just check and just help me in solving this question. So we have question is given, I believe 2 and pi is given. Question is 2 kilonewton, 20 kilonewton. I've given question is yes 20. Okay. So first of all, there is a surcharge. What is the pressure intensity due to surcharge? Suppose PS, I'll be writing as that Ka into Q, right? For that, we need to find out the value of Ka. Okay,
Sir, it is passive case, sir.
passive case, yes, yes, passive case. So I'll be writing over here, compute the total passive pressure. This is the advantage of people solving the question in the class itself. You can point out the discrepancies, if any, by the teachers. Kp into Q.
Q.
What is the formula for the passive coefficient of earth pressure? What is the formula?
1 plus sine phi by.
1 minus sine phi. We have solved this previously. We'll get 3 as the answer, right? We'll get
Yes,
3
sir.
as the answer. So 3 into, I guess, 20. Isn't it? 3 into
Yeah.
20. I'll get a pressure intensity of 60 kilonewton per meter square. Isn't it? 60
Yes.
kilonewton per meter square. Now, for the passive pressure intensity, how can we write the passive pressure intensity for the soil? Cp is equals to gamma H tan square alpha plus how much? 2CH tan alpha, isn't it? Gamma H tan square alpha plus 2CH tan alpha. Am I right?
Yes, sir.
Yes. So 45 plus 45 plus 15, 5 by 2, 15 is 60, tan 60 is how much? Tan 60 is root 3, tan square 60 is 3. So tan alpha value will be uh, tan alpha is root 3 and tan square alpha is 3, isn't it? Tan square alpha is 3. So here, okay, for the pressure intensity, I will not write this equation at first. I'll write gamma H, no, there will be one H less, 2C tan alpha. There won't be any H in here. It will come at the end while calculating the force per meter. So this is constant, right? It is not dependent upon the height. Okay, and this is dependent upon the depth of the wall. So you can find out this separately, or you can find out this what to say together. So value of 2C tan alpha is how much, Abdul?
I got 60, sir.
Value of 2C tan alpha 60. Tan alpha is root 3, 2 into 60 into root 3.
Sir, actually, surcharge, the effect of surcharge, effect of surcharge already I have done it, na, sir?
Yes, surcharge I have done. Okay, but
Okay.
in this passive pressure equation, this thing is constant, right? This is not. This will not.
Yes,
We will be
yes, sir.
considering this thing as constant, and then this thing as variable, changing with the depth, isn't it? It has a height.
Yes, sir.
So I'm asking you the value of 2C tan alpha. What you have got?
The total value is 300, sir. 309.
No, not total value. What is the value of 2C tan alpha? You have got. It is 60 root 3, right? That is 2C tan alpha is 40 root 3, I believe.
2
Now
seat.
calculate 40 into root 3. 69.28. And gamma H tan square alpha.
69.28, sir.
Yes, gamma is tan square alpha is gamma is how much? 20, H is 4, 20 into 4, 80 into 3, that is 240, isn't it? Gamma H is 240.
Yes, sir.
Okay, so now what I'll do, I'll take a separate page, delete this. I have to draw the pressure distribution diagram, right? I cannot draw it over here. So it is 240. So since we have calculated all the pressures, we can now draw the pressure distribution diagram. How many parts does the pressure distribution diagram have?
Two parts, sir.
Two
Rectangle
parts.
and trapezium.
Okay. Just see, I am drawing something. It will be a bit different. Different. This is the height of 4. This is the first surcharge. Okay.
Yes. Yes, sir.
Then this is the constant part of the passive
Yeah.
pressure, and
Yeah.
this is
Now
the
triangle.
yes. So you're considering these two rectangles as one, right? That's why
Possible,
you're
sir.
saying
Possible.
yes. So it is P1 of the surcharge. This
It
is
is 60.
P2 of the constant part, and this is P3. If I write like this, then this is this will be P2, and this will be P1, and this is PS. I'll write PS over here. Okay, this is self-explanatory. P2, P3, P1. Wait, no, I'll write it properly. This is P1, this is P2, this is P3. Okay, so this is like this. So here, what can we say? At the base, we have for the P3 we have how much? 240, right? For the P2, the constant part, we have how much?
69.28. 69.28.
69.28. Yes. And for this, we have how much? 60.
60. 60.
60. And the height is 4 meter. And the height is how much? And the height is
4
4
meter.
meter. So it is very easy to now find out the thrust per unit meter, like P1 and P2 and P3. Okay. So P1, capital P1 will be how much? 60 into 4, right? 60 into 4, 240. 240 kilonewton per meter acting at 2 meter on the base, right? Isn't it, Abdul?
Yes, sir. Yes, sir.
Yes, yes. Okay. You have solved like this, right? Means
Yes,
you
sir.
have
I have
solved
taken entire diagram as a single trapezium, sir.
yes, yes. No, no worries. You can solve it like this. But uh, my sole aim when you are solving it in the examination, okay, you can do it
Yes, sir.
whatever you want because the answer needs to be correct and the pressure distribution diagram needs to be appropriate. Okay, but I am showing
Yes,
it
sir.
to differentiate between the components of pressure. I am considering separately. Okay, because it will be required for application purposes later. It might be required. Okay, so here what I am doing, I am taking it separately. P2 will be how much? 69.28. I believe into 4, 277 approximately.
277.12.
Yes, 277 approximately. Yes, 0.12. Okay, kilonewton per meter. I am writing again meter square. Please pardon me. At the rate, how much? Again 2 meter. Again 2 meter. And P3 will be half into base into height, half into base into height, that is half into 4 into
480.
240, that is 480. 480 kilonewton per meter at the rate 4 by 3.
1.33.
1.33
33.
meter from the base. Now total pressure is how much? P will be acting the summation of P1, P2, P3. I believe it will be at the rate not at the rate. It will be total 997.12
0.2
kilonewton
kilonewton.
per meter. Yes, and the Z will be how much? Z will be
1.67 meter.
1.67. That is P1 into 2 plus P2 into 2 plus P3 into 1.33 divided by P. Divided by P.
Divided by total P.
Total P. Yes. So it
Yes,
is
sir.
how much? 1.677.
67 meter.
1.67 meter. Okay. Clear?
Yes, sir. Yes, sir.
1.67 meter means this is the between it is 2. So at some point like this,
Nearby
1.67
middle.
meter. Okay. Z bar will be active. I hope it is clear.
Yes, sir.
Okay. Once you have solved this, the other question will be self-explanatory. Okay. You have solved this question also, I believe.
Yes,
Good
sir.
copy. Okay. So you have to find out the active thrust per meter length of the wall. So I'll be directly using Ka equals to half gamma h square, not Ka, sorry,
PS.
Pa, yes.
Or PA, not PA also, FS, sir.
Yes, Fa. I'll add capital P in order to differentiate
Okay.
between the pressure and the force is equals to half Ka gamma h square, and here I need to find out the value of Ka. What is the formula for Ka, Abdul? Over here,
It's cos alpha into cos alpha minus square root of cos square alpha minus cos square phi.
cos alpha into
Cos
cos
alpha minus
cos alpha minus square root of cos
cos
square
square alpha
alpha minus
minus
cos
square phi.
square phi divided by cos alpha plus root over of
Yes.
cos square
Same.
alpha minus cos square. This is phi and this is
Fine.
also phi. Okay. Alpha is over here 15 degree, phi is 30 degree. Okay, phi is 30 degree. The material is sand, it is cohesionless, there is no need to worry about the cohesion. So putting everything in the formula, what is the value of Ka you are obtaining?
0.373.
0.373. Okay, right, correct, 0.373. Now you have a unit weight, it is given as 20, unit weight H is 6. Putting this in the formula using the 0.373, what is your answer about the active thrust per unit length of the wall?
134.42
134.2.
kilonewtons per meter.
134.42.
42, yes, sir.
42 kilonewton per meter. Okay. Okay, so this formula is important. This formula is what differentiating between the rest of the sums from this sum. Clear? All right. I believe. No, I believe in the book. Okay. The next sum, I hope you have solved and you have got that water table. No, first this sum. Yes, you have solved this sum, right? 36 wall of
Yes,
4 meter
sir.
height. This is the way you have solved this sum.
Yes, sir.
Yes. So what am I doing? I am first calculating the value of the coefficient of active earth pressure using the formula 1 by 3. We are obtaining the value. Then lateral pressure intensity due to surcharge Ka into Q 1 by 3 to 36 12. We draw a rectangle with 12 as the base and the height as 4 meter. Then pressure intensity due to backfill is P2 equals to Ka gamma into H. We get 24. We draw a triangle of base 24 and the height 4 meter. Then we find out the what to say, total pressure intensity as the base is okay. Find out the total force per unit length of the wall, that is P1 into H, area under the this rectangle and the triangle, and find out the position of their action from the base. That is 4 by 2 is 2 meter from the base, the centroid of the rectangle, and for the triangle it is 1 by 3 of 4, that is 1.3 from the base. Now again we add the two pressure, the two force per unit length of the wall, we get 96 kilonewton per meter, 96 kilonewton per meter wall as the total force to thrust, and Z as P1 into ZP1, P2 into ZP2 divided by P1 plus P2, we get 1.67. Okay, I believe it is self-explanatory. Okay, now the next sum you have solved, Abdul.
The water table.
Yes, you have solved this sum, right? I believe you have solved this sum. I cannot hear you right now. Okay, so if the water table is there, you have to remember two things first. There will be a pressure due to the water present, and there will be pressure due to the submerged soil, which will be acting as the no, there will be a pressure due to submerged soil, and above that, the pressure due to the dry soil will be acting as a surcharge for the submerged soil. So here you can see P1 is a surcharge. P2 over here, the small triangle over here, you can see this is the intensity of pressure of the dry soil, which is acting as a surcharge in the submerged soil, that is P3. For the submerged soil, the unit weight, the intensity of pressure of the submerged soil is P4, and the intensity of pressure due to water is P5. Okay, so we find out all the pressure intensities. P1 as Ka into Q, 12 kilonewton per meter square as the surcharge pressure. P2 as the dry soil pressure, Ka into gamma into H1. H1 is 1.5. It has been mentioned that water table is at a depth of 1.5 from the surface. P4, we don't need P3 because P3 equals to P2. Okay, P4 is Ka gamma submerged into H2. Gamma submerged is given 12, and H2 is the depth of the submerged soil, that is 2.5 meter. 10 kilonewton per meter square is the result, and P3 is pressure intensity due to water, that is gamma W into H2, 9.8 into 2.5. Next, we calculate the area. Once we have the diagram ready, it is very easy to calculate the area and find out the centroid. This is a rectangle, this is a triangle, again a rectangle, and then two triangles we have. So first of all, we find out the thrust due to the surcharge and the point of action, then thrust due to the dry soil, and then the thrust due to the dry soil acting as surcharge, and then the thrust due to the submerged soil, and the thrust due to the water. In each and every case, we find out the point of acting of these forces. We add up all these forces to get a value of 120.41 kilonewton per meter as the total pressure acting per meter length of the wall. Okay, and then we do the same formula, P1 into Z P1, P2 into Z P2, everything divided by total P. We get a value of Z bar equals to 1.5 meter. Okay, so a force of 120.41 kilonewton per meter length of the wall is acting at a height of 1.5 meter from the base of the wall. Okay, I hope it is clear.
Yes, sir.
Yes. Okay.
Sir, here in this question, default we have to assume there is no any weep hole.
Yes, no, weep hole don't need to assume any weep hole. If weep hole needs to be assumed, that means the water is discharging, right? Water is
Yes, sir.
discharging, so that will be mentioned in the question. Okay, it
Yes,
will
sir.
be mentioned in the question.
Default, if nothing is mentioned, you have to take the
Yes,
water
submerge,
consumption.
submerge. Yes, every time
Yes, sir.
if there is water mentioned, submerge unit weight plus the weight of water as a pressure intensity. Okay,
Yes, sir.
okay. This question also you have solved, I believe. What is your answer of this question?
Same, sir. 121 kilonewtons and 1.49 meters. Which question, sir?
This one, the vertical excavation. Next question.
Uh, Vertical. 1 minute, sir. 1 minute. Sir.
Okay, vertical.
Critical quotient value 20 kilopascals
Yes,
and FA is 360 kilonewtons.
FA is 320 kilonewton. I'm getting over here.
360.
360 you are getting.
I think, sir. I
Okay,
don't know.
check it.
Maybe.
Okay, check it. If there any discrepancy, I will just mark it over here if you are correct, or else you can correct it yourself. See, the formula is critical height of unsupported excavation is 4c by gamma tan alpha, right?
Yes, sir.
4c by gamma tan alpha, it is tan 45, phi is equal to 0, phi equal to 0, right? I have mentioned fixed angle is 0, yes. So tan alpha equal to 1, so it is 4c by gamma. So c equals to hc into gamma by 4. Hc is 4, gamma is 20, divided by 4 is 20. C is 20, you have obtained that, right? So for the active earth pressure, you have to use this formula, half
Yes,
gamma
sir.
h cot square alpha. Cot square alpha is 1, cot alpha is 1, so half gamma h x gamma h square it will be, gamma h square and 2ch. So 8 into 8, 64 into 10, 640, yes, over it is correct. Then 20 to 8 into
Sir,
20,
they
320,
here
yes.
they have forgotten 2c square by gamma, sir.
No, 2c square, not 2c square. It is 2ch cot alpha. Where it will be
No,
2c
sir.
square.
For active
Yes.
case here, we are neglecting the negative zone.
No, see, no, no, not negative zone. I am just asking, you just forget about the negative zone. There was a
Okay.
question in the MCQ, right? The cohesion
Yes.
reduces the active pressure by this amount. The
Yes, sir.
cohesion reduces the active pressure by this amount. This is the amount 2c cot alpha. This is the amount by which the
Yes, sir.
cohesion is reducing. So at a depth of h, it will be reducing this by an amount of 2c cot alpha into h, right? 2c cot
Yes,
alpha
sir.
into h. So this needs to be subtracted from the main part, and this particular subtraction is the effect of cohesion on the active earth pressure. Okay, I'm not talking about the zone of tension crack, how much it is there. No, this is, suppose I have told you, na, this is one site. This is suppose site A, and this is suppose site B. Suppose this is site A and this is site B. So in site B, when I'm placing it behind a retaining wall of 8 meter height, okay, what is the value of, what is the generalized value? Okay, see it like this. What is the generalized value of active earth pressure will be obtaining? Okay, so when we are talking about generalized value, we have to take the depth of the entire retaining wall, that is 8, as h. Now the pressure intensity equation is how much? Is what? It is half, not half, control z. It is
Yes, how much?
gamma h, right? It is gamma h cot square alpha minus 2c cot alpha. This is the pressure intensity, isn't it? At any depth h or at any depth z, if we write there z, the gamma z cot square alpha minus 2z cot alpha. Okay. Now I have told you to find against the wall total active earth pressure, that is thrust per unit length. So we will be multiplying this. This is a triangular area, half into h. This will be h square. This is written wrongly over here. This will be h square. Okay, half gamma h square cot square alpha minus 2c cot alpha into h. So here I believe it is correct, because 20 into 8 is 160 to 2 320. This is the answer. Is it clear?
Sir, can you draw the pressure distribution diagram for the B case, sir?
Present distribution, pressure distribution diagram.
Yes,
Okay,
sir.
what is, this is the generalized distribution diagram, right?
Yes, sir.
This is the generalized distribution diagram. So if this is the height of h, we don't know what is happening in the tension trap depth. We are neglecting that. But over
Yes.
here, whatever the value was supposed to be, it was this value, right? Generalized form. It was this value. That is being reduced by an amount called 2c cot alpha. You know the generalized distribution diagram for the Rankins active earth pressure for cohesive soil, right? In that
Yes,
distribution
sir.
diagram, at the base, whatever the value was that was supposed to be, it is not there because something is subtracted. Something is subtracted. So what am I doing? I am taking that entire equation and finding out the active pressure case for PA. That is for the height of 8 meters. Clear?
Okay, sir.
It is just a generalized equation. There is no specific case of tension crack depth involved over here. And similarly, in the next case, we are finding out the depth, the passive pressure, half gamma h. It will be again h square, tan square alpha plus 2ch tan alpha. You add this, you'll be getting 640 plus 320, that is 960. Okay. Is it clear, Abdul? Any doubt?
Yes, sir. Passive only
Yes.
still a little confusion is there for me. I don't know why it is.
Where
And
it is the confusion? Tell me now.
so, may I know the source of this one, sir? I will go through once.
Yes, this sum has been given from the book of BC Pulmia, but you don't need to go
Okay.
through the sum. You go to the generalized case of active earth pressure distribution for the case of cohesive soil.
Yes, sir.
For
Yes,
the
sir.
case of cohesive soil, any
Yes, sir.
any pressure distribution diagram will show you that at the
Mm.
base the pressure
Mm.
intensity would have been gamma h cot square alpha, right? Gamma h cot
Mm.
square alpha, but due to the effect of cohesion, it is being reduced by gamma h reduced to gamma h cot square alpha minus 2c cot alpha
Okay,
minus
maybe
2c.
I did not understood the question properly. I have to read the question. Then
Yes,
only I will come
that
to
is
know.
that is the thing. That is
Yes, sir.
calculating
Yes.
total active earth pressure. See, nothing
Mm.
is being
Mm.
mentioned in the question. That is the thing. Nothing is being mentioned in the question. Always go for
Mm.
the generalized conception.
Okay, sir.
Go for
Okay.
generalized conception. Here I have mentioned total active earth pressure, total passive earth pressure. This generalized equation. Go for that. Okay.
Okay, sir.
And
Okay.
I mentioned over here any case of what to say tension track depth and all. You need to consider
Okay.
that. You need to show that in the diagram and then subtract it again like that. Okay.
Okay. Okay, sir. Okay,
Okay.
sir.
Fine. Last question also you have solved, I believe.
Done, sir.
Yes. It is like this, right? You've got the same
Yeah,
answer.
trapezium. Trapezium, sir.
Trapezium. You
Two
have
one 219.42 kilonewtons.
219.42. I've got 219.812. Okay, there might be some discrepancy in the
And
decimals. Okay, it is acceptable.
Y bar is 2.069.
2.069, 2.7. Same way, you have to calculate. It is 16 degree, so Ka is 0.568, right? The value of
Yes, sir.
earth pressure coefficient. Okay. Okay, so I'll not uh, repeat this sum. I straight away.
Yeah, it is a repeated question. It is
Yes,
almost
it is a
repeated.
repeated question. It is given just for practice sake. I will not repeat this sum. Okay.
Yes.
So I'll go to the MCQ. The first one is this one. What is the answer?
Uh, the first one is C, sir.
Yes, very good. Lateral pressure. If I had mentioned over here in the case of active state, then what will be the answer?
Vertical pressures.
Vertical pressure. Very good. Very good. Okay. Next question. Effect of cohesion. I have mentioned over here. Effect of cohesion is what does it do? Reduce the
Option
active pressure intensity
D, I
by
think.
yes
Option D, na, sir?
D. Yes, 2C cot alpha.
Yes, sir.
Yes. And the next question is also a repeated thing.
Yes.
Bell's equation. That is the equation I have used over here. This is the Bell's equation. Well, not this one. This is the Bell's
Yes, sir.
equation. Okay. Pressure intensity is the Bell's equation. This one. PA equal to gamma H. In the Bell's equation, it is what is the answer?
Say minus 2C cot alpha.
Minus 2C cot alpha for Z equal to 0. Yes, very good.
Instead
Now,
of giving in a square root of Ka, it is given in the alpha form.
yes, yes, yes. Alpha.
Okay.
Same thing. What is the answer of this for smooth walls?
D, sir.
I, no. For
0.
smooth, for smooth walls, del is considered as 1 by 3 into 5. And 2 by 3 is for ordinary retaining walls. Ordinary retaining walls. And 3 by 4 is for rough walls. Okay. And it is 0. It is 0 when we consider vibrations.
Mhm.
When there is vibration, that is, suppose we are considering seismic analysis, okay, dynamic analysis due to earthquake pressure and all, then it is considered as 0. Okay.
Okay, this answer is I made wrong answer here.
Okay, yeah. For smooth wall, the value of wall friction is taken as 1/3 of 5. Okay.
Okay,
Now, with
okay.
respect to this question, I'll just talk about, we'll just discuss about your doubt in the last class, that is
Yes, sir.
wall friction, right? So,
Yes, sir.
I have seen in this book the value of Ka when wall friction is being incorporated, it is sec theta cos
Yeah, big formula is.
phi minus theta divided by root over of cos theta plus del plus root over of sine phi plus del into sine phi minus beta, yes, phi minus beta divided by cos beta minus theta, and this entire thing taken as the whole square. Okay, this is the value of Ka. Now what is the value of phi? Phi is the angle of internal friction. What is the value of beta? Beta is the angle made by the backfill. Okay, angle of the surcharge with respect to the horizontal. What is theta? What is theta?
What is that, sir? Eta, theta.
Theta. In the first, in sec theta cos phi minus theta. This is theta. And then below cos theta plus del, this is theta. Okay, theta plus
Okay.
del plus root over of sine phi plus del into sine phi minus beta divided by cos beta minus theta. What is theta? Theta is the angle made by the wall
On the with respect to
vertical axis.
horizontal,
No, vertical axis.
vertical, sir.
Yes, vertical axis.
Okay.
Wait, I'll just confirm. You are saying horizontal, I'm saying vertical. Theta is, yes, vertical axis. Okay. Why will not be vertical? Because see, when I'm tilting something, the whenever we are considering the retaining wall, okay, the assumption is the wall is vertical, right? So whenever the wall is tilting, with respect to which axis are we measuring the tilt? Vertical axis, isn't it? Because by default it is vertical. Okay. So this is the value of, this is theta. What is del? Del is nothing but this one, wall friction.
Wall friction.
Okay. Now you tell me, now see, del has been incorporated over here with sine, isn't it?
Yes, sir.
Where it is being added to phi. Phi is an angle of internal friction. Okay. And del has been also incorporated in here with cos, where this del has been added to theta, the angle of tilt. Now you tell me, because of the addition of del, what will happen to the value of Ka?
Denominator, its value is
Increasing, right?
yes,
I'll tell
yes,
you
sir.
in a more detailed way. This theta value, it is being expected to be very less. Okay, because the angle
Yes,
of
sir.
tilt will seldom increase 20 degree. 10-degree
Yes, sir.
also will not increase. Okay,
Yes, sir.
and
Yes, sir.
del we can see over here in these options 1/3, 2/3, 3/4. Del will be always a fraction of phi. Del will be always a fraction of phi. So if phi is 45 degree, if phi is 45 degree, del will be 1/3 of 40, that is 15 degree, isn't it? So del will
Yes,
have a significant value. Okay. Now we know below 45 degree, cos is more than sine, right?
yes,
Cos
sir.
value are more than sine, and after 45 degree, sine value are more than cos. So in this case, in the first part of the denominator, cos theta plus del, there is a high chance that this angle will be less than 45 degree. Okay, this angle will be less than 45 degree. But in the second part, sin theta plus del, there is a high chance this angle will be more than 45 degree. So because of the incorporation of del, the cos value and the sine value both are increasing, isn't it? Both are increasing, and so the value of Ka is decreasing, with respect to which we can say that the wall friction will decrease the active earth pressure and it will increase the passive earth pressure, because passive is just the reciprocal of the active, isn't it?
Yes, sir. Yes, sir.
So is it clear to some extent?
Yes, sir. Clear, sir. Clear, sir.
Yes. So I have only what to say, I have only derived this using this equation. You can also go for your own explanation or derivation if you can find out in any other book. Okay. But yes,
Sir,
when you are
this
talking,
last question,
yes.
this last question, what you have given, wall friction question, objective.
Okay, yes. One question, objective. Okay, yes. Okay, this one, yes.
These are uh,
Yes.
these options A, B, C, D. Is it from codal provision, sir?
Codal provisions, I will not say, because nothing sort of the code has been mentioned over here. See, the the effect of wall friction, to understand, it also depends on the roughness of the wall, smoothness of the
Yes, sir.
wall.
Sure.
Yes,
Yes, sir.
okay. So
Hmm.
when you talk about roughness and smoothness, nothing is absolute. It is just an
Okay.
eye estimation. Okay, just an
Okay.
eye
Okay.
estimation. So these are roughly assumptions. or you can say approximations which we can consider. Okay,
Okay, sir.
assumptions or approximations. You can find out the explanation, the derivation, and also your doubt regarding the active pressure, whatever you had in this question. In the book of BC Punmia, I have given all the sums from the examples and the
Sure, sir.
theoretical questions from that. You can see the book and you can go through the derivations very carefully in order to clear any doubt that you might have left. Okay.
Thank you. Thank you, sir.
Yes, okay. It was a very interactive class and it was very nice that we have solved all the questions and you have
Thank you.
given a good response. Okay. So the earth pressure, this part 2 of the earth pressure has been completed. I believe it is over.
Yes, sir.
Okay.
Yes, sir.
I'll wait a minute. I'll stop sharing. Stop presenting. So in the next class, we'll be studying about the introduction part of the stability of slopes. It will not have so many numericals. It will have the basic understanding of stability of slopes. And I'll also be taking a summary session. I'll be dropping a mail to the coordinator of the NPTEL today. On the
Yes, sir.
next day, that is on Monday, there will be a summary session of the entire course of soil mechanics or geotechnical engineering. Next Monday, on 16th. Okay, on 16th there will be a summary session from 4 p.m. to 5 p.m. It will have one or two questions from all the sessions and it will be a revision class of 1 hour. Okay, so on
Yes, sir.
15th we'll meet with introduction to stability of slopes and on 16th, the next day from 4 to 5 p.m. there will be a summary session. Okay,
Yes, sir.
okay, thank you.
Tomorrow class will be same, na, sir. Almost you don't
Yeah,
have
tomorrow
any.
I think another teacher will be taking the class. That will be same.
Okay, sir.
Because the Monday's class is scheduled from 6 to 8, right? 6 to
Yes,
8 you
sir.
are scheduled. I'll be taking the summary session the next Monday from 4 to 5. Okay? From 4 to 5.
Okay, sir.
Okay. Okay. Thank you for attending
Thank
the
you, sir.
class.
Good night,
Yes.
sir.
Yeah. Good night. Bye.
Good night. Thank you, sir.
Thank you, sir.